Vectors. Question 10. This one right here now, it says a transformation T is defined by the matrix T equal 2 minus 1 to 0. The point A, which is minus 2, 3, is mapped to the point A prime, AB under T. And it says find the values of A and B. And so, in order to find the image, what we have to do is multiply the point A, write A as a vector. In vector form, it is minus 2, 3, and it is pre-multiplied by the matrix transformation that it is undergoing T, and that will give us the image AB. So that will give us the image. So we have to do matrix multiplication. So T, which is 2 minus 1 to 0, it is being multiplied by A. So it's T times A to give you A prime. So we know we multiply it to row by column. So we go row by column. So that is going to be 2 times negative 2 plus minus 1 times 3. And then down here now, it is going to be row by column, which is 2 times negative 2 plus 0 times 3. So we're going to work that out. All we have to do is put that in our calculator. Put that in our calculator, and what we get is, this is minus 4, minus 4, minus 3 is minus 7. And then this is now minus 4 plus 0 is minus 4. So that will be A, but that would be A prime, sorry. And so we can therefore state that A would be equal to, well, common A would be equal to negative 7. And we can tell them now that B would be equal to negative 4. Easy, soft. All right. Now part 2, it says determine the transformation matrix that will map A prime back to A. So to find the transformation matrix that will map A prime back to A is going to be the inverse of this matrix. It's going to be the inverse of this matrix. So the matrix that's going to map this is the inverse of this matrix. And so the inverse of this matrix, so I can really call it, let's call it T prime, which is the inverse of T. So it will be 1 over the determinant of T, and the determinant of the T is the product of the leading diagonal minus the product of the non-leading diagonal. So 2 times 0 is actually, 2 times 0 is 0. Let's put it 2 times 0 minus product of the non-leading now is minus 1 times 2, minus 1 times 2, and then this is going to be multiplied by T, and matrix T is 2 minus 1 to 0. So in all, it's going to work out to be, we know that 0 minus minus 2 is just 2, so it's going to work out to be a half of, this should have been the adjoint in here, sorry. This should have been the adjoint. Remember, to write down the adjoint, we interchange the leading diagonals and we negate the non-leading. So we interchange the leading to put 0 right here and 2 right here. Then we negate minus 1 to get 1, then we negate 2 to get negative 2. Then a half of this is what will be the transformation that maps A prime onto A. So that's 0, 1, minus 2, 2, and then a half of all of this is going to be, a half of 0 is 0, a half of 1 is a half of negative 2 is negative 1, and then a half of 2 is 1. So this would be the transformation matrix. Nice. All right, so let's continue. It says another matrix P is defined by 0, 1, 1, negative 2. Find the 2 by 2 matrix represents a combination transformation of T followed by P. So it undergo T followed by P. So we're going to work out the matrix PT. So working out the matrix PT, that's T followed by P. We work out the matrix PT. So the matrix PT is just 0, 1, 1, 0, 1, 1, negative 2. And this is now T, and I think T was going back to what? 2, negative 1, 2, 0, 2, negative 1, 2, 0. And so when you work it out, this is going to be equal to row by column 0 times 2, 1 times 2 is 2. Then row by column 0 times 1 is 0. This time this is 0. Then row by column 1 times 2 is 2. Then plus minus 2 times 2 is minus 4. So 1 times 2 minus 2 times 2, that's negative 2. And then row by column is negative 1. So I'm getting 2, negative 2, 0, negative 1. That's the single transformation that I am getting. It says, hence find the image of the point 1, 4 under this combined transformation. All right, so the image of 1, 4 is, you're going to write down 2, 0, negative 2, negative 1, and it undergo the transformation of 1. Images, the object is 1, 4. When you work that out, what we're getting is row by column, row by column. So it's row by column is 2 plus row by column is 2 plus 0 is 2. And row by column is negative 2 minus 4, that's negative 6. So 2, negative 6 is the image. Just to make sure you did it right, you can actually check out what you would get if you were to multiply T first by this and then let it undergo P. So this is a check. I just like to do what's called a check. So doing a check, then I can just work out what is. It undergo T first, where T is 2, negative 1, 2, 0. So just to do my check first, where this is 1, 4. Do my check first. Row by column, that's 2. That is 2. 2 minus 4 is negative 2. And then row by column, that's 2. That's negative 2, 2. And then negative 2, 2 must undergo this now afterwards. Negative 2, 2 must undergo P now. Just checking if we're right. Then make it undergo P now. P is 0, 1, 1, negative 2. So it's going to undergo that now. So the negative 2, 2 undergo this to become row by column. That's 2. Yes, we are right. 2. And then row by column is negative 2 minus 4, which is negative 6. So we'll get the same thing. So good. This is just a check to make sure we never make no mistake. So good. All right, we're nice. That takes care of that. Finally, we're at the last question on the paper, the vectors part. And it's a very easy vectors question. Surprisingly, it give you a diagram and tell we A be a M, A to B a M, DC a 3M, and AD a N. So that means a B, well, we don't know what's BC yet. Now it says complete the statement. AB and DC are parallel. They're parallel. AB and DC are parallel. And the modulus of AB is 1/3 times the modulus of CD. The modulus of AB is 1/3 the modulus of CD. That's clear. All right, that's so clear. All right. Now it says express BC in terms of M and N. Express BC in terms of M and N. So to go from B to C in terms of N and N, to go from B to C, you can go from B to A to D, and D to C. So BC are going to equal to, go from B to C, it's from B to A, which is minus M, plus A to D, which is N, plus D to C, which is 3M. So BC work out to just be N plus 2M. That's BC. All right. It must have got something about something. It says L is the midpoint of CD. Find BL in terms of M and N. So L is the midpoint of CD. Here's L, and find BL. So we want to go the journey from B to L. This is where we want to go from B to L. To go from B to L, since L is the midpoint, then we know that from D to L is 3M over 2. DL is 3M over 2. So clearly now, BL are going to equal from A to B, then from A to D, then from D to L. That will give us BL. All right, that will give us BL. So if we just want to write it here, BL is going to be equal to from B to A, which is minus M, plus from A to D, which is N, plus from D to L, and D to L is 3M over 2. So when you don't add up that now, what we're getting is 3M over 2 plus 3M over 2 minus M, 3 over 2 minus 1, that's a half. So this works out to be M over 2 plus N. That's BL, M over 2 plus N. So go write it around here now, just M over 2 plus N. So vector BL is equal to M over 2 plus N. Nice, I'll finish. I'll finish with a couple minutes to spare. We have about 10 minutes left, 10 to 15 minutes left. You can just go back through your paper, make sure everything is fine with you. Nice and easy, soft. All right, now don't forget to please just subscribe and help the channel to grow. Videos will get better. You'll get many more videos to come in the future, but just to help out the channel, subscribe.